Welcome to the third video in this short series on creating a die set. We recommend you watch the videos in order, so watch the other two first if you haven't yet. In this video, we will continue to add values into the setup dialog, which we will then link to the work, like we did in the previous video. We wish to thank you for your interest shown in Cimatron and hope you will search out other videos in this series. Let's edit the stack heights in setup and start adding fields for all the different plate thicknesses. We'll create variables for the die shoe, die backup plate, stripper backup plate, and stripper plate. We'd already have something set up for the coil, so let's add the punch plate, and punch backup plate, and punch shoe. So we got all the plate thicknesses in one place. This demonstration uses a full and clear name for each variable. You could use abbreviations to make the formula shorter. To make the table represent the plate order, drag and drop the variables into place. That way, if we create a diagram, we can use it to show all the plate thicknesses from top to bottom. And it might help us organize things better. Now we'll start creating the values. For the shoe, there is a list of standard sizes available. So we'll create a drop-down list using this from list option. Enter the options here that you want to be available in the setup drop-down list. We can do the same for punch backup thickness. We need that in here because that's going to be used in a formula. For the stripper backup, let's suppose there is only one type of backup plate we want to use consistently across all our dies. And we'll do the same for the stripper plate. We have already got a value for coil thickness. Now we can add the die backup plate and then the shoe plate as lists as well. As you have seen in the previous videos for a from to list, you provide a minimum value, a maximum, and then the incremental distance. We'll go from 25 to 100 in steps of 25. When that structure is set up, we can pick the values that we want. You can see here how the drop-down lists have been populated with our values. Now we can start assigning these. Double-click the shoe. Click the thickness dimension. Click the Setup button. And link it to the field in Setup. Follow that same process for the punch backup plate. Next, we go out to the stripper plates. For this demo, we will skip the punch plate thickness and handle that later with a formula. Using the setup table like this makes life easier when editing because all your dimensions are right there in one location where you can easily manipulate the data. Finally, assign values for the die backup and the die shoe thicknesses. Let's go to the end view to make things simpler. For the demo, I will make some changes to the values in the setup table and check that everything is bound correctly. And you can see the model has updated. Now let's create a variable that we're going to use in several formulas. We'll call this press travel. It will represent the distance between where the stripper plate touches the top of the coil and where the punches have finally fully entered. This formula will calculate the distance between the highest point on the actual strip, or height minus z, and the lowest point on the strip, or height plus Z, and we will add in a safety margin. We get both those values from the Strip Layout tab. That should define the maximum starting point of travel that I need. Let's create another variable called stripper close gap. This defines the distance left between the punch plate and the stripper assembly at full press travel. We will specify this value manually. Add another variable named stripper closed height. This is a formula where we will use some of the parameters we have just created. So select Formula in the drop-down and choose the values. So working from the top of the die, we need the coil thickness plus stripper plate plus stripper backup plate plus the variable we just created called stripper close gap. Add all those things up, and we have the overall distance in closed position. So now it's time to link these variables to our assembly. So here we have the punch plate distance from our die, currently set to 50. This is our stripper closed height, so let's link those. Now it's shown in closed position. You see the 5 mm gap. Remember, we have left a couple of variables with a value of 0. One of those is the stripper width. We want the stripper to cover the width of the coil, so we'll create a formula to assign it to the workpiece width, and then we can attach it by picking the dimension. Go to the stripper and pick the dimension. Using a side view, we see everything as it happens dynamically. Link the variable. Remember, in the previous video, we created margins on our overall widths for our die steel. We can duplicate that process here. So here for the die plate, we attach my workpiece width plus a value. For now, let's go with 50. We need space to add some material guides. So we must also increase the overall width to accommodate the punch and die steel. So let's increase that to 100. And update. Now we need to add a new component for our material guides that will keep the coil in place as it slides along underneath the stripper. Activate the die assembly. We need one on each side, so call it Material Guide A. To locate it, let's switch to the top view. We'll put one here at the top using the UCS like we did with all the other components. And sketch our first material guide. It has to sit on top of and be the same length as the die steel, so we will attach it with references. Sketch a rectangle. We need a gap here, so we shall include that as part of the sketch. Again, we can use a reference. By placing a dimension on that gap, we can control it in Setup. Let's give this guide an overall width and some height. Extrude it. And there we have our first material guide. Make sure our assembly is active and now add material guide B. Add it to the top of the die steel again and use the main UCS. We will add references to the front and back edges of the die steel as well as the side of the stripper. We'll create the guide using these references to the front and back edges of the die. Leave a gap so we can dimension the actual gap distance between the stripper and the material guide. We need to dimension the width and then extrude to the same thickness. Now we have a rough set of material guides. We can link that back to setup. We'll need a couple of variables to use in of our stripper sizes. The first will be for the clearance between the stripper plate and the material guide. We want to make sure we always have enough room in there for the coil to slide through. So we'll call that material guide clearance. Later, we will need to input and control this value, so let's set a nominal 1 millimeter. Now we'll make the assignment here. Pick the value and then we'll assign it to setup. You can see the guide moved over to that 1 millimeter distance. Repeat the process on the other side. It's a good idea to oversize the dimension when you sketch so that you can clearly see the changes when you do assign the right value. That way you know the relationship works. Let's add a width for that material guide. This is probably will never change. Let's use 50 millimeters. You don't see a change because the component is already 50 millimeters wide. Set the value for the other side too. Now we can do some final linking in the setup. Previously, we added these clearance values into the formula for the die width. We want this die set to be fully reactive, so we're going to add the thickness of our material guide. Remember to add it twice. Now if we do change the width of the material guide, it will update the overall die steel, which will change the stripper plate, which will update the punch. So the stack is going to work nicely with that formula. Thank you for reviewing this presentation. Look for our next video in this series, which will be talking more about die design.